Welcome to episode 154 of George's Random Astronomical Object, a podcast that contains no artificial food coloring. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so interesting to astronomers. So let's turn on the random number generator.
Go.
The coordinates from the random number generator are 5 hours, 38 minutes, 54.6 seconds for ascension, and plus 26 degrees, 18 minutes, 57 seconds declination. This episode's coordinates point to the object A0535 plus 26, also known as HD 245770, located at a distance of roughly 6200 light years or 1900 parsecs in the constellation Taurus. The history of the, quote, discovery, unquote, of this object is rather complicated. Originally, it was included in the Henry Draper catalog, which dates from the early 20th century, as a really bright, relatively massive blue star, and it was thought to be just a single blue star for a few decades. In the 1970s, however, the Ariel 5 satellite detected variable X-ray emission from somewhere around this region of the sky. Although because X-ray detectors were not that good in the 1970s, people weren't sure exactly where the X-ray emission was coming from. At this point, this X-ray source was given the designation A0535 plus 26, where the A stood for Ariel and the digits gave the location in the coordinate system that was in use at the time. Eventually, this variable X-ray emission was associated with variations in the light from HD 245770 seen in the visible part of the electromagnetic spectrum, which implied that the star was the source of the X-ray emission. So it turned out that the object was not a single large blue star, but instead a special type of binary star system called a high-mass X-ray binary. The progenitor for one of these star systems would have contained two very bright blue stars with masses multiple times the mass of the Sun that would have each initially fused hydrogen into helium in their cores. However, these stars only last a few million years in this stage, and the more massive one would have evolved into a red supergiant and then exploded as a supernova, leaving behind something like a neutron star or black hole, while the other star would still be in the hydrogen fusing stage. In the typical high-mass X-ray binary, the stars are close enough that the smaller object would gravitationally strip away gas from the bigger blue star, and as that gas falls onto the smaller object, it would get gravitationally compressed and really hot, thus leading to the production of X-ray emission. However, A0535 plus 26 is an abnormal high-mass X-ray binary, so it doesn't do that. Instead, it belongs to the special class of objects called BE high-mass X-ray binaries. That's a large capital B and a small letter E. The bigger blue star in this case is a special type of giant blue star called a BE star. That's a large capital B and a small letter E again. This designation indicates that, in the spectrum of the star, it's possible to see very bright line-like features at specific wavelengths that are produced by an extended cloud of ionized gas surrounding the star, which is kind of weird by itself. In A0535 plus 26 specifically, and BE high-mass X-ray binaries more generally, the gas surrounding the BE star lies within the disk. The orbit of the neutron star or black hole in these specific systems is actually very elongated and elliptical, and can take a relatively long amount of time to orbit the bigger blue star. In A0535 plus 26 specifically, the smaller object is a pulsar, which is a rapidly rotating version of a neutron star, and the pulsar completes an orbit around the bigger blue star once every 111 days. Most of the time, the pulsar is too far away from the giant blue star to really affect the blue star's outer gas layers at all. However, the pulsar will occasionally pass through the disk of ionized gas surrounding the larger blue star. And when it does that, part of the gas disk falls onto the pulsar, gets really compressed, and produces X-ray emission. Since it takes a short amount of time for the pulsar to pass through the gas disk, it looks like the star system is producing a relatively short burst of X-ray emission rather than continuously emitting X-rays. This variable X-ray emission has now been studied intensely for 5 decades. However, the X-ray bursts have not always been consistent. In 1995, the X-ray bursts ceased, and A0535 plus 26 effectively went on hiatus. I guess sort of like webcomic creators, YouTubers, and podcasters, A0535 plus 26 needed to take a break. And sometimes when people go on hiatus, their webcomics and podcasts never come back. But other times they come back after a few months or a few years. Well, A0535 plus 26 returned from hiatus in 2005. It seems like the gas disk surrounding the giant blue star in the system disappeared for a few years and needed to be regenerated. The system also did not just make a comeback, it came back even stronger than before. In 2020, A0535 plus 26 produced one of the brightest X-ray outbursts ever measured from the system. A0535 plus 26 was definitely one of the first BE high-mass X-ray binaries ever identified, and it has been instrumental in helping to define this entire class of abnormal X-ray binary star systems. As long as it doesn't go on hiatus again and never come back, astronomers will continue to observe this object to unlock the secrets of how this class of binary star systems works. The location on the Earth's surface corresponding to the position of A0535 plus 26 in the sky is located within agricultural fields outside of Kara Azam in the Indian state of Bihar. One of the most fascinating things about Bihar generally is that it produces most of India's vegetables, including potatoes, onions, eggplant, and cauliflower. However, I can't really tell what exactly is grown in the location corresponding to A0535 plus 26. I also don't know which vegetables could be most closely compared to an X-ray outburst. Maybe cauliflower comes the closest. The website for this podcast, which is not going on hiatus anytime soon, hopefully, is www.randomastronomicalobject.com, which you can visit to read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy, and the sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.